Hello everyone and welcome back to Flying Through the Helicopter Flying Handbook. This is the video for Chapter 6, which is all about weight and balance. So weight and balance is very important for any aircraft. It's especially important for helicopters. And why is that? Well, helicopters are more complicated, as always. In an airplane, for example, we only worry about the total weight and the balance in the longitudinal axis. But for a helicopter, we also have to worry about the lateral or side-to-side weight and balance as well. Just because of the way the helicopters fly, they're more sensitive to that. Now, of course, we haven't even introduced some concepts such as sling loading, where you have an external load on the helicopter, and that just makes things even more complicated. So when you look at weight and balance, how do I calculate my weight and balance? Well, a couple of concepts first. We have this thing called empty weight, basic empty weight. What is it? Unusable fuel, fluids that you normally would have in the helicopter, things like that. So this is what the helicopter weighs when it doesn't have any useful stuff in it, if you will. And to that, we're going to add passengers, maybe some cargo, and fuel, of course. That will tell us if we are above the maximum gross weight, and we want to stay below that. Because if we're above weight, helicopter's not going to perform very well. We can actually be too light. So there are some helicopters that have limits. This is the minimum weight that you can take off with in this helicopter. Because, for example, if it's a Robinson, say, and they have those rotor systems that are, resulting in the whole SFAR 73 because of their issues, well, if it's light, then you're more likely to get into those problems that have led to SFAR 73. You also need your aircraft to be balanced. If the aircraft is not balanced, then it will not perform appropriately. So if your center of gravity is too far forward, you might not be able to flare in an auto rotation, or you might not be able to essentially stop if you're trying to come into a hover because you don't have enough aft cyclic to overcome that extremely forward CG. Now, if it's extremely aft, then you'll also have issues with that, right? Then now you're having a hard time going forward because the CG is too far aft. And of course, there's the side-to-side limits as well. So how do we calculate weight and balance? You just need to know that your mom is warm. So your moment is your weight times your arm. So you can do those calculations. Now, something I like to do is I like to make a spreadsheet for any kind of aircraft that I might be flying. So I wanted to walk through this spreadsheet really quick. So here's a weight and balance for a Schweizer S300 CBi that I fly quite a bit. So you'll see that it has a certain empty weight, and that is 1184 pounds. And the helicopter has been weighed, and they found that its arm, well, its total moment, if you will, is this much in inch pounds, and the arm longitudinally is at 100.2. So you're going to say, well, what does that mean? So we have a datum line that we use to reference for both axes. And in the case of the Schweizer, it's a 0.100 inches in front of the main rotor mast. So the CG is slightly aft by 0.2 inches of the main rotor mast for the basic empty helicopter. Laterally, that arm is 0.78 inches. So that datum line for that dimension is at the middle of the helicopter. So that is 0.78 inches to the right. Okay, so to that, we just add our different pilots. So we have a pilot. I just had an example pilot that was 220 pounds, and an arm of 83.2. So you can get this out of your manual for the helicopter. So if you look at the flight manual, we talked about this in the previous video. You look at chapter 8, it's all about weight and balance, and it'll tell you these arms for these various items. You just look it up and you plug it in. So very simple calculation. You'll notice here I just said, hey, it's just the weight times the arm. That's the moment. And here's the lateral arm. If it's the pilot, they sit 12.8 inches from the center. And for the passenger in this Schweizer, they sit on the left, and that is minus 13.8 inches. And you can calculate the moment. So what you can do is you then add up all the moments. So here we've added up all of these moments and we came up with this number. And then to get the arms, we add the moments in each direction and we divide by the weight. So here I have a total weight with no fuel of 1629, and that gives me a longitudinal arm of 95.55 and a lateral arm of 0.389. Now what? Well, usually you want some fuel. So if I add in the fuel and I said I'm going to have 20 gallons of fuel, and fuel weighs 6 pounds per gallon. So that's a pretty simple calculation here. Here's the arm from the manual. Here's my moment. Here's the lateral arm. Fuel tank is on the left in this helicopter, so it's minus 17 inches. And that's my lateral moment associated with that. And I can add that to my empty weight, and I end up with a total weight of 1749. This helicopter is good up to 1750, so I'm good. And here's my arm and my arm. So in a little bit, I'll show you what this looks like if I look at a chart. So I'm going to have a little chart that I grabbed out of the manual and I essentially put it into Excel. Okay, and there are some options. We can take the doors off. The doors weigh 5 pounds each. So the weight is going to be minus 10. And here's the arm. Now, I could have done a calculation for each door separate, but that's just a little weird. Normally, if we take one door off, we take off the other one, although you can fly it with just one door. Okay, so then we have limits. So here I've plotted out the limits that came from the manual, and then I have a couple of lines. So this is as I fly and I use fuel, I will move down these two lines. So we have the doors off line and we have the normal line with the doors on, if you will. Now the Schweizer doesn't have any other kinds of limits. The only limit is your CG has to be in this envelope, laterally and longitudinally. Incidentally, if I bring up this manual, you'll notice that I've sort of inverted this. They have longitudinal here and lateral here. But those are the only limits for the CG in the Schweizer. So real quickly, I want to show you a much more limited machine, a R22. Okay, so for the R22, it again has a basic empty weight. You'll notice it's 300 pounds lighter than the Schweizer. And the moment and arm, and this is stuff you're going to get out of the helicopter, right? Every helicopter is going to have a weight and balance sheet in it. And then we have a pilot. We have a couple of lighter pilots here. We have a 190-pound pilot and a 208-pound pilot, and we're going to use 6.5 gallons of fuel. And I just wanted to show you this briefly because what I've done here that's a little bit different is the Robinson has a limitation with the weight versus the lateral CG. And this is fairly common that you'll find. It's just that the Schweizer doesn't have this kind of a limitation where the maximum weight is 1,300 pounds. And you'll notice here with these two guys and the doors on, we're actually outside of the weight. And if we take the doors off, we're just touching it. And then as we fly, we get a little bit lighter and we go further in. Now, in terms of the CG, we're okay. So here's that same CG diagram. So for example, if I were to use the same weights as what I used, I think I said the pilot was 220 and 230. Even with only 6.5 gallons of fuel, I'm already 50 pounds over, so I'm not going to perform very well. And if I look at my limits, notice I'm way out here now, and that's not good. This helicopter is not going to perform, and I've also exceeded my CG limits. So this helicopter is really not going to perform. Not a good situation. You've become a test pilot, essentially. All right, so let's see how this affects us in the sim. So I'm going to go ahead and load up my trusty Schweizer. I'm going to click on the customize here in X-Plane. You'll notice there's a weight and balance section. So I can use the default weight and balance. Interestingly enough, you'll notice by default, they overloaded this thing. Also, there is an option for 2 tanks on the Schweizer. So this one obviously has the 2 tanks. It's got a left tank and a right tank. I'm going to go ahead and say, hey, we don't have the left tank, and we're going to have 120 pounds or so in the left. And I have about 2 hours of flight time, which sounds correct to me. You'll notice they also have the ability for a slung load, and you can select the object that you want to sling and how much it weighs. So that's something that's fun to practice with if you want. Okay, so let me just go ahead and say, yep, that's good. And I'll start up. All right, so I'm just going to do some quick hovers. So this is flying pretty normally here. I'm able to hover with just 20 or so inches of manifold pressure, even though I'm flying in the rain, apparently. I can hover backwards. I can hover forwards, and everything is pretty simple. So I'll just go ahead and put it down on the ground. Okay, and now I'm going to reconfigure it. I'm going to up the weight. I'm going to start with the defaults. I'm going to go overweight, and I'm also going to move the center of gravity. And we'll see how this flies now. And it's taking about 24 inches to get off the ground instead of 20. And it's pretty hard to fly. I'm trying to keep it from going forward, and I'm not being very successful. So it's pretty sluggish here. All right, now what if I go the other direction? Okay, so now I am still overweight, and I have an extremely aft CG. Let's see what that does to me. I'm pushing forward a lot on the stick here. And once again, it's requiring a lot of forward stick and a lot of power just to kind of move it at all. So It's just very sluggish. And you might notice, it's probably hard to tell from this video, but my nose is pretty far up because I have such an aft CG. So if you have a forward CG, it's going to have a nose down attitude. And if you have an aft CG, it's going to have a nose up attitude. Okay, so that is what it's going to look like in the Schweizer if you change the loading conditions. Okay, what if I select an R44? Once again, I can customize my weight and balance. Now, I don't have the ability to necessarily change what is going on in terms of the different passengers. You know, it's a limitation of this particular helicopter in my sim. Some of the helicopters will allow you to set things by passengers. So here I have my sort of default weight. I have my empty weight of 1505 and my max weight of 2500, which honestly, this is a little bit low. Most of the R44s that I've flown at least are closer to 1600 pounds, and they have around 900 pounds available for all the fuel and allegedly 4 people. All right, so if I just fly this with normal CG, it should operate as you would expect. Go ahead and just pull it into a hover. And it's all normal, right? I've just got a normal CG. I can hover forward. I can hover backwards if I like. And everything is fairly simple. Go ahead and go back to forward flight. Still flying in the rain here at Mount Pocono. Now let me change it. So now we have full fuel, and we're going to put at least a few people in there. So we're going to be a little bit overweight and with a forward CG. All right, so let's see. Can we even get it off the ground? So as soon as I start pulling the collective, it tries to nose over. I've got, yeah, I can't even pull it off the ground here. I've got the cyclic fully aft. And it just says, no way. If I continue, it's just going to nose over and crash here. And you'll notice I've got, I'm getting up to 20 inches and it says, okay, I'm kind of going to take the tail off the ground, but that's it. We go back to the defaults here. And notice I'm not really even that much overweight. I'm overweight by 4 pounds, but that's enough to really hurt me here. Okay, so now I have just one person. Let me go with, we'll say, a couple of guys that are maybe a little larger. And you know what? We'll put somebody in the back. That's what we're going to do. We're going to put a couple of bigger people in the back seat. We'll say they're both 300 pounds, which is the max. And we'll say that our pilot is 220. So that should be 820 or so. So we're overweight by 100 pounds. What if I'm going to go just a little bit aft on the CG, not too much. We'll see, does this even fly? All right, now I can feel it picking up the nose, and I'm having to push forward on the cyclic. Pushing forward, forward, forward. Really pushing forward. Okay, I've got like full forward on the cyclic, and notice I'm above the red line. I'm barely in a hover, and I can almost stop this aft motion. It would be nice if these different helicopters in the sim actually had the ability to change the lateral CG as well. But, you know, it's an airplane world. I always tell my students that, and everything in aviation is pretty much set up for fixed wing stuff. So even the simulators that have excellent models for helicopters don't have everything that you could possibly want. That is all for this video. I hope you enjoyed it, and we will see you in the next video.